Hello everyone, welcome back to the channel. Today we will look into how to create a directional hit indicators with full screen shader. For this, I'm using Unity version 2022.3 and I have a project set up in URP. Now with that out of the way, let me roll the intro. I have gone ahead and created full screen shader and material and also applied it to our renderer feature. I have also set the inject point to before rendering post-processing. If you don't know how to set up a full screen material, I will link the full screen shader introduction video in the description. In the shader graph, go to Graph Inspector. In the graph settings, select the blend mode to additive. Now let's create a texture 2D property. Call it main texture. I have cooked this splash texture, which I will set as a default. Then check this use styling and offset and drag it in. In order to work with texture, we need to sample it, so create a sample texture 2D node. Feed our texture into it. Let's create a color property. Call it base color. Set the mode to HDR. Give some default red color. Drag it in. We will multiply our base color with our main texture. Then feed our multiply node's output into this base color block. We also want to control the opacity of our effect so we can fade in and fade out. For that, let's create a float property. Call it alpha. Give default value of 1. Set the mode to slider with range 0 to 1. Drag it in. We will multiply our alpha with our main texture. Then feed the multiply node's output into the alpha block. We will rotate our texture in the direction of incoming attacks. For that, let's create a rotate node. Keep the units to radians. Then take rotate node's output and feed it into sample texture 2D nodes UVs. We will rotate our texture by calculating angle between our player's forward direction and the direction of the attack. So let's create two vector 3 properties. I will call them player direction and hit direction. Drag them in. We will calculate the angle using dot product, so let's create a dot product node. Feed our directions. Dot product returns the values between -1 and 1. It returns 1 for parallel vectors, 0 for perpendicular vectors, and -1 for opposite vectors. Then to get the angle, we will take our dot product node's output and feed it into arccosine node. Arccosine is the inverse of cosine operation. Like we pass angle in cosine to get the value, similarly we can pass that value in arccosine to get the angle, but in radians. However, there's a catch. On a 2D plane, assume this is our forward vector. If I have the direction that goes diagonal to the right side, I will get the dot product of 0.707. So based on our dot product, we will get the angle of 45 degrees. Now if we have the direction that goes diagonally towards the left, we will get the same dot product of 0.707, which will give us the same 45 degrees, which will rotate our effect in the right direction, which is not the desired output. To fix that, we will take the x component of our direction and compare it to the x component of our forward vector. If our direction's x is greater than or equals to our forward vector's x, we will use the positive angle, otherwise we will use the negative angle. So to do that, we will split both our directions using split node. Then we will create comparison node. It will compare input A with input B based on this condition. We will take X of our hit direction and feed it into A. Then take X of our player forward and feed it into B. And we will check if A is greater than or equals to B. Then we will take our comparison node's output and feed it into branch node. Think of branch node as if statement. So if our hit direction's X is greater than or equals to our player forward's X, we will pass -1, otherwise we will pass 1. Finally, we will multiply it with our angle from the arc cosine node. Now take our multiply node's output and feed it into rotate node's rotation. Now I know I have said that we will use positive angle if our hit direction's X is greater or equals to player forward's X, but our effect rotates in opposite direction as if it is mirrored, so I have just flipped the order in branch node. That's it for our shader part. Save our shader, head back into scene view, adjust our material. Make sure to adjust the tiling and offset so while rotating, it won't tile on the screen like this. Now I have this BazookaMan, which also has a script with the same name. All it does is, when I hit the spacebar, it shoots the projectile. Pew, pew. I also have this projectile prefab that has a collider, a rigid body, and a script called Projectile, which just destroys our game object on onCollision enter method. Finally, we have our player that has a collider, a rigid body, and a script to handle our HitVisuals, where we pass both our hit directions and alpha to our material. To calculate the hit direction, we will get the position of a projectile on onCollision enter method, then we will subtract the position of our projectile with the position of our player to get the direction vector. Then we will make the direction vector parallel to the ground and normalize it. Now before we dive into our HitVisuals script, I'm using twinning library from asset store called LeanTween by Dented Pixel, which I will link it in the description below. In our script, we are taking reference of our material, then this fade time and animation curve is used to fade in and fade out our effect. In onCollision enter method, we are checking if our player is collided with projectile. If so, we are passing our projectile's position into calculate hit direction method. In calculate hit direction, we are getting the direction vector and then I made it parallel to the ground and normalized it. Then we are passing the normalized direction to set material properties method. In set material properties, we are passing our hit direction and our player's forward to our material. Then we will animate the alpha with the LeanTween. So first we will cancel all the tweens running on the game object. Then we have created a value tween which will run on this game object and goes from 1 to 0 in the specified fade time. Then set the interpolation based on our animation curve. And this delegate might look intimidating at first, but here all we did is, while our tween is updating, we are getting the new alpha value and pass it to our material. In Unity Editor, I have set the animation curve so that our effect quickly fades in and then slowly fades out over the course of 2 seconds. Let's hit play. Now if we get hit from the front, pew, our effect will point to front and then fades out. If we get hit from behind, pew, yep, it points behind. Now if we get hit from this angle, pew, yep, So now we have our basic hit indicator system. Yay! That's pretty much the video. If you find the video helpful, consider like, share and subscribe. If you have any questions, post them in the comments. That's it from me, and I will see you guys in the next one.